I'm going to talk the way you can build up large companies using smaller ones. And this technology is quite an old one. It's even mentioned in the Bible. If you remember the Babylon Tower, it fell down because of the lack of communication. That's exactly the point we're going to cover. A few words about Mellanox. This is a company that's been on the market for 18 years. It's based in Israel, and virtually all the developments are done in Israel. However, we have representative offices worldwide. We employ over 3,000 employees, and we're a public company. We provide network solutions, the so-called end-to-end solution, cables, cars, routers, switches, and that means we give the ready out-of-box solution starting from 10 gigabits up to 100 gigabits. Currently, we have the full production, and by the end of this year, we're going to have 200 gigabit technology available. We work and we provide two types of networks, Infinimop and the Internet. In this case, I believe that Ethernet is the most relevant today, but nonetheless, we have a lot of companies who produce Infiniment as well. Over 30 years ago, I got this type of phone. This is a cellular phone. It was in a small case, and I thought, oh, it's a nice machine because I may use it. And I can get in touch on the go. Whenever I'm going home, I can call my wife and kids and parents. And at that time, I couldn't have imagined that in less than 30 years, based on this machine, we're going to produce such gadgets. And you can use and to read newspapers, write emails, play games, and you can do everything in the toilet, in the bathroom. That means that the amount of information, the most interesting thing is not what we do with this machine, but what the machine does with us. When you read using Kindle, when you read this book on an e-reader or on your cell phone, you know, sometimes it's difficult to understand whether you read the book or Kindle reads you. When you set such applications, there's a question whether this application may use your webcam. The reason is they want to read you. It looks when you smile, when you cry, what you're more interested in. And in this way, they use it to make the selection of the books you may be interested in. And the amount of information generated by all these pieces of equipment is really immense. And thanks to the development of data storage technologies as well as storage technologies, all this information is stored somewhere. It is recorded and stored. But 1,000th part of this information is used, and there is a great gap between what we have and what we can do. And when the gap is triple as large, you cannot pass it just using simple standard means. You can do something really specific. Just simple improvement is not enough. You need to do a changeover. Currently, we are in the year of revolution. In PC, when we start doing the volume in machine, when there's, it just executes one command that switches to the other one. But currently, we process data using neural networks. It's the model that processes data based on the way we think, based on the way our brain operates. In this way, this equipment may process immense volume of data, and it has two data types. One is the real-time data, the other type is the offline data that it gets from the archive and for the equipment configuration. That is why we have two stages. One, neural network training, when we actually teach our equipment to differentiate between cats, dogs, and find some specific features and traits or images. And secondly, it may get the real data, the new data it has never seen or worked with, so it's able to describe what it is. This information processing is performed using different resources. There are some people using GPU, and they use it quite actively. And video share value has drastically increased because people are trying to use machine learning. And all this is working in large enterprises, networks, and our contribution is the network that will enable you to create a large equipment, large machines for data processing. We do have specific equipment, including network computing, and you can do the part of machine learning operations within your network. A long time ago, over last century, when somebody wanted to use new resources, it would buy a new piece of equipment. If you need a more powerful equipment, then you buy a more powerful one. This is the scale up. At some time, we decided that this approach is inefficient, and that we need to use a different approach. We use the scale-out approach. That means if you need a resource, you buy the resource, but you use it, the one who has access to it, and the way the person uses it is not attributed to one machine, but to a bunch of different ones. And in order to make this possible, we used remote direct access, memory access, RDMA. This is the main technology enabling the equipment running on one machine to use the resources available in a different end of the network. This app may use one process, one application may use the resources available in different network. This is what the RMA enables you to do. If you have a regular network, then, for example, when you do the data storage, but frankly speaking, it works for GPU and what's so not. If the blue machine wants to request the data located in the green one, the CPU on this green machine takes part in sending the data to the blue machine and back. But here we have two problems. First of all, green machine, it also has some applications running. It means that part of CPU power is redirected to the blue machine, to the blue PC. But the most terrible part is that the time and the computing power for the green machine depends on what is happening on all other machines. And if somebody wants to address the resources located in my PC, my CPU, instead of computing my data, will compute the requested data. Our DMA does this following. All data transfer is done based on the network hardware, and the CPU takes virtually no part and no role in this. And if anyone wants to use the resources on the green machine, it uses the network hardware to exchange the data, and the CPU in the green machine uses no computing power for this operation. And this allocates more resources to the green machine, and the application time is highly predictable. You see they're smiling here, and they were used to cry on the previous one. The first ones who realized this was Oracle. Oracle company started to cooperate with us back in 2002, that is 15 years ago, And it took them 5 years to make the Oracle rack based on the InfiniBand or RDMA. And when they switched from 10 gigabit network to 40 gigabit on InfiniBand, they got application processing speed increase not by 4 times, but by 50 times. You know, it's great when you have a broadband network, but the way you use the resources on all the machines and pieces of equipment is exactly the thing that really matters. And other companies did exactly the same. One company that does not let us name their names because these companies believe that their IT is their competitive advantage. That's why they do not like speaking up about this. But nonetheless, when working with our networks, they did the recovery for Oracle database and shrinked the recovery from 1 week to 4 hours. When sometimes the recovery procedure took 7 full days, now they can do it in 4 hours. And Microsoft SQL is able to analyze 1 petabyte of data. I believe it's like 1 with 12 nodes per second, in 1 second. This is significantly faster than you could have ever achieved on an old technology. Currently, we use 100 gigabit technology. That is why you may process even a vaster amount of time. It's great when they use it, but frankly speaking, they found out it's not that easy to create the machine. Microsoft, Oracle may combine and assemble this machine, but when Lenin used to say that every cook may manage and run the state, but we don't know whether it's true or not, but we want everyone who wants to have a cloud solution or anything else, that they could do this. That is why we did in Mellanox a blueprint. We call it CloudX. That is, we created standard server and standard disks, and we did the rack that is used with our equipment, with our hardware, and we use open source or our in-house developed software. That's why we have such so-called CloudX appliance. We compare it with the operations and with the hardware, but it works on a traditional protocol. And we get, a double speed in broadband and pass-through increase. When you get 100 gigabit technology about 2 years ago, Microsoft, that was one of the first, started to use the RDMA on the Skylab data centers, Azure. They're using our technology, and they got over 2 terabytes of data processed in seconds for storage, and 2.5 million TPM for the database application. Somebody said before lunch, something like about 45,000 TPM is good, but here we get, 100 plus times advantage. And quite recently, IBM and Tencent, they said, Terrasoft competition, and they took the first prize, overwhelming the champion of the last year virtually 3 times. The last year champion used the traditional 10 gigabit TCP, and in order to get the thing they got, they used over 3,000 servers. And IBM did exactly the same, using 512 servers, using 100 gigabit network, RDMA, and our technology as well. That means they managed to drastically increase the speed, drastically reduce the energy and power consumption, as well as area and space usage. Yet another example of RDMA use. This is Ceph. This is the object storage This is open source product, and we worked with the Chinese company XSky. We did it together with them. We switched TCP to RDMA and RPS to RDMA, and we got 3 times more operation per second as compared to the conventional network. Frankly speaking, the network is the same, but when using RDMA technology, we increase the productivity. Ceph is works with our customers, including the Russian company Krok. You can see the metal enter. They use Ceph. And installation ranges from a few dozens to several hundreds of nodes. Ceph RDMA is better. It's in the upstream better. And general availability will take place this summer. So, I'd like just to say the following. There are some respectable companies like PayPal. They've created a special cluster for fraud detection, and they said that they could not do that without any other technology but ours. They do this, they use InfiniBand. They have a very interesting technology. They recognize and do the authentication the way the user operates the mouse. And for example, Baihu, they use the machine artificial intelligence solution. You know, the first machine created 2 years ago that is able to identify the images better than the person. It means that it does this in a more accurate way. Microsoft Bing Maps, fully based on InfiniBand, Azure and Microsoft Azure, works using our technology. And if anyone goes for Microsoft or Skype or anything else, you are passing through our cables. And to sum up, I'd like to say that in Manax we give everything for your data centers, everything you need today, and we get everything. You get everything you will need today or in the future. We have a few technologies we haven't spoken about. I try to do that for database and storage centers, but we have machine learning technologies as well as security, network security. This is what you get from us. And our philosophy and strategy is not to make CPU offload. CPU offload we also do, but that is not enough. Our philosophy is not to decrease the load from the CPU and take a bigger chunk of pie we have, but we want to make the pie much bigger than what we have now, and then we'll think about the way we're going to divide it into pieces. Thank you very much for your attention. You're welcome to ask any questions you have. Is everybody too shy? Or is everything so clear? It looks like everything is absolutely clear. Thank you. Okay, we have a 10-minute break. Oh, we have one question. Thank you very much for your presentation. You've mentioned network computing. Could you please go into details? What is network computing? Network computing. On our routers and switches using InfiniBand, we have a floating point engine. There is a machine, a device that can perform floating point operations on the data that pass through the network. We did it because of the high-performance computing request. This is for the MPI, collective operations, but we did it in such a way that you may do the data reduction operations as the data goes through the network. Apart from MPI collectives, that is 10 times faster than when you do at the nodes, as we do it today. we have two areas that people show interest in. On the one hand, these are the people who do the search. For example, let's imagine you want to find the picture of a specific person, then you send out this picture to 100,000 pictures, 100,000 nodes with these pictures, and every node checks the database, finds the database with a best match, then it gets evaluation on the match value, and then it returns the answer to the requester. If you get 100,000 requests, you get 100,000 replies, and you want to find the best one. And if you do that, they sort out in the network the time I'm getting the answer, and when I get the exact answer I'm looking for, then it's much faster and much more efficient as compared to conventional ones. But doesn't it require additional computing power? The difference is that it's the computer commutators and routers that do it. Yes, absolutely, we do the computing in routers, switches, etc. And you get not only separate floating agent points, but you also get additional features. It by design works in parallel. It enables you to process more, it uses more processors, more CPUs, and they work in parallel mode. Thank you. Do you have any plans to install GPU into your routers and switches? I don't think that this or coming year we're not going to install integrated GPU, but if we look at the trends and in the model modes, that CPU is not a single unit but a cluster, then probably we just do more and more processing in the network. Last year we purchased as a chip company that produces processing systems. I haven't mentioned that. It's our new product line, Bluefield. When we do the integration of ARM processors with our adapter power product line and switches, we already have switching point. Then probably we'll do it in the future, the GPU installation. Thank you.